Okay, so today we're going to deal with the power rule of exponents. And this first part is just going to be kind of setting it up. And then we're going to do some more difficult examples. So let's get the basic idea behind the power rule. So the first idea is like, oh, we're going to square some things that have already been like raised to powers. And what is that going to do? Well, we're going to treat this just like normal. So since this is squared, what do you do with normal squared things? You times whatever your base is, and our base is this, by this many times. So let's times our base that many times. Well, 3 times x to the fourth times y to the negative 2 times our base again, 3x to the fourth y to the negative 2. And so now we have this. Well, if you remember from yesterday, like these things are actually all separated by multiplication, so they're not really connected. The first thing I will do is I'm going to pull out all my numbers, which are the 3's. I'm going to pull together my x's. And I'm going to pull together my y's. Now if you remember, like this one's pretty easy to do, which would just give us 9. If you remember from yesterday with our x's though, x to the fourth times x to the fourth will give us x to the eighth, because multiplication of exponents acts like addition. And then same thing with over here, y to the negative second times y to the negative second will give us y to the negative fourth. This would give me a final answer of 9, x over that, and y to the fourth, because this would really be on the bottom. Here's what I want to do though. I kind of want to look at what happened to these exponents compared to their original numbers and see if there's a faster way. Well, it looks like the 4 was just times by 2 to get to 8, and the negative 2 was times by 2 to get to negative 4. So there's a faster way to do the power rule. The faster way is, hey, this thing up here really is just multiplying the exponents of all of the numbers on the inside. And you can even see like 3 is to the first power. Well, 3 squared is 9. Oh, look at that. So this outside number actually multiplies all of the inside numbers. And that's what really happens. Let's try another example with this. Okay, so let's take this example now. And we're going to use the shortcut because writing this thing out 4 times would not be fun. So as we learned last time, the shortcut is you take this, and it really just multiplies all of the exponents. First thing that you need to do is you need to take the whole number that's out in front, kind of give it an exponent. So since that thing really didn't have an exponent with it, it's really to the first power. So anything that doesn't have an exponent is always to the first power. Okay, so we're going to take that number and times all of those. So that'd be 4 to the fourth, x to the 12th, y to the 16th, and z to the negative 12th. We could probably evaluate this thing. So again, like I'm going to need a calculator for this because I don't know that off the top of my head. So 4 times 4 times 4 times 4, 256. So that'll be 256. X to the 12th, y to the 16th, and because that's a negative z, we would put that underneath. So that would be my final answer. Again, the power rule, from what we learned last time, is it kind of acts a little bit like distribution to all of the exponents. Let's try another example. Okay, so in this example, we kind of have 2 different situations. We have like this power rule situation happening over here, and this normal numbers that we'd multiply over here. what you always will deal with is the parentheses first. So we're going to take this, apply the power rule to all of the numbers. And again, I want to give 3, even though it wasn't raised to the first power, I want to make it raised to the first power. Well, y squared is going to give us y to the 6th, because 2 times 3 is 6. X to the negative 3rd will give us x to the negative 9th, because negative 3 times 3 will give me negative 9th. And 3 to the 3rd will be 3 to the 3rd. And again, at this stage, I want to combine all of my like terms. So I want to do 2 times 3 to the 3rd, which would be 2 times 3 times 3 times 3. So that'd be 54. I want to combine my x's. Well, this is 1x, and this is negative 9, so that would give me x to the negative 8th, because 1 plus negative 9 is negative 8. And then I have 1y here, and 6y's here, so that will be y to the 7th. Now I probably would like to rewrite this to be a little bit nicer, which would be 54 y to the 7th over x to the 8th. And again, it's just nice sometimes to know, oh, x to the negative 8th, that's division, so it should be on the bottom. Okay. We're going to try just 2 quick more examples. Okay, so as you can see in this example, we kind of have 2 power rule examples. So these are 2 power rules. Again, you want to deal with both sets of parentheses before you do anything else. And again, the first thing we want to do is if you have 5 to the, like if you have 5 and it's not to an exponent, we need to give it a 1. So I'm just going to go through here and everything that doesn't have exponents, give it a 1. Then again, we'll use the power rule by distributing this multiplication. So 5 to the 2nd, x to the 2nd, and y to the 4th. And then we'd go over here and distribute the 4, so 3 to the 4th, z to the 4th, x to the 8th, y to the negative 12th. Again, the next step, just like always, is to combine these like terms. So we're going to have 5 to the 2nd times 3 to the 4th, and that gets our numbers together. Now we would like to get the x's together. So we would have x to the 2nd times x to the 8th, and then we'll get the y's together. So we have y to the 4th and y to the negative 12th. And the last thing that we'll get together is the z's, but we only have 1 z, so there's really, we'll just add that to the end. Let's do some of these things. So this first one, well, 5 to the 2nd would be 5 times 5, and that's 25, and then we have to times 3 4 times. So that's a big number, 2025. This would become x to the 10th, because 2 plus 8 is 10, and that's what happens when we multiply. It acts like addition. This would be y to the negative 8th, because 4 plus negative 12 would be negative 8, and z has nothing happening to it, so it's just z to the 4th. We could again rewrite this and get 2025 x10 z4 over y to the 8th. Okay. We're just going to do one last example. I know I've given you a lot of examples in this because I really want you to be able to see how this pattern works. The last one we're going to do is just going to have a fraction, just so nobody panics about a fractional problem. So let's do this fractional problem. First thing you want to do, again, this fraction doesn't have it's not raised to a power, so we will raise it to a power. Then using the power rule, we're just going to kind of distribute. So I'm going to have 1/2 to the 3rd. Oh, x to the 9th, and y to the 12th. Fractions, if you remember from the beginning, we would just have to do 1/2 times 1/2 times 1/2, which that would give us 1 times 1 times 1, which would be 1, and 2 times 2 times 2, which would be 8. So this would be my final answer. I could also write this as x to the 9th, y to the 12th, and 8 on the bottom. Okay. Try these problems. Again, your assignment's going to kind of be a matching assignment for this.